Morning light reaches the apartment before anyone fully wakes up. The sun has already been working for several minutes before anyone thinks about it directly. Light moves across the kitchen counter, across unopened mail, across fingerprints left on the refrigerator door from the night before. A parked car outside warms along one side first. Thin condensation pulls back from the windshield in uneven patches while the street remains mostly quiet. Somebody pours coffee without turning on the larger lights. Dust hangs inside the sunlight near the window. Not dramatically illuminated, just there, shifting slightly whenever air moves through the room. The kind of detail people stop consciously seeing after enough years in the same environments. Water heaters cycle on. Elevators begin carrying people downward. Traffic signals continue changing for almost empty intersections. Birds start making noise somewhere beyond the buildings. Apartment walls expand slightly as temperature moves through them. Almost all of it depends on one star remaining stable for another morning. The unusual part is how fully that dependence disappears into routine. The coffee cools beside the window anyway. A delivery truck reverses somewhere outside. The warning tone echoes between buildings for a few seconds before fading again. Somebody walks downstairs carrying keys and a gym bag. Another person stands at a sink waiting for toast to finish without looking outside once. Morning routines continue with the confidence of repetition. Not optimism, exactly. Closer to inherited trust. The sun rises. Rooms warm gradually. Plants turn toward windows. Solar panels begin pulling electricity from light that left the star a little over 8 minutes earlier. Nobody wakes up wondering whether fusion remained stable overnight. Inside ordinary life, that question barely feels real. But long-term stellar stability is not a universal condition. Some stars pulse unpredictably. Some brighten and dim without useful rhythm. Some release enough radiation to slowly strip atmospheres from nearby planets. Others burn through stable periods too quickly for complex systems to adapt around them at all. The sun does something comparatively rare. It remains consistent long enough for biological and technological systems to organize themselves around expectation instead of contingency. Not perfectly consistent. The surface still twists, erupts, and throws charged material into space. Solar storms still move through the system. Satellites occasionally fail because of them. Electrical infrastructure on Earth sometimes absorbs delayed consequences through damaged transformers and overloaded grids. But overall, the behavior remains stable enough that civilization treats it less like an active astrophysical process and more like part of the architecture of reality itself. The light entering the apartment now feels ordinary, partly because generations before this one experienced nearly the same light. The same color temperature through windows, the same seasonal angles, the same predictable return through cloud cover, winter air, apartment blinds, suburban kitchens, glass towers. A stable star became infrastructure before humans understood what stars were. Outside, more windows begin lighting up across nearby buildings. For a few seconds at a time, you can see separate lives framed inside them. Somebody ironing clothes, somebody sitting motionless at a table reading messages from a phone. The television already running while the sky behind the room remains pale gray. Small private routines unfolding simultaneously beneath one long-lasting source of heat. It is difficult to emotionally process how much depends on that continuity. Not only warmth. Agriculture, ocean circulation, atmospheric chemistry, biological timing, migration patterns, sleep cycles, food systems. Even Earth's orbital distance has remained unusually cooperative for a very long time. There are probably planets where conditions never stabilized long enough for expectation to form this deeply. Some may freeze repeatedly. Some may orbit flare stars that keep resetting surface chemistry before complex ecosystems can persist. Some may hold oceans briefly, then lose them. Others may spend millions of years beneath skies too unstable for biological rhythms to fully settle around. Meanwhile, people on Earth complain about cloudy mornings because sunlight arrived slightly weaker than usual. The apartment grows brighter without asking permission from anyone inside it. Dust continues drifting through the beam near the window. The coffee is cold now. A child somewhere outside asks whether it will rain later today. Someone else checks the forecast before leaving for work, assuming tomorrow will resemble today closely enough to schedule around it. Trains continue arriving. Offices fill gradually. Screens brighten across entire cities within the same narrow stretch of morning. Civilization behaves as though stable sunlight is permanent infrastructure. For now, it almost functions that way. Not because permanence was guaranteed. Only because one relatively calm star remained predictable long enough for living systems to mistake temporary stability for a normal feature of the universe. The stars above the fields do not change very much from one lifetime to the next. That mattered long before astronomy became formal science. A farmer stands outside before sunrise, holding a wooden tool darkened by years of hand contact. Cold air settles low across the ground. The soil still carries moisture from rain earlier in the week. Above the horizon, familiar bright points appear where earlier generations already learned to expect them. Planting seasons return consistently enough for memory to become useful. That consistency changes behavior. You can build calendars from it, harvest systems, religious festivals, navigation routes. Boats crossing open water at night learned coastlines partly through stars that returned to nearly the same positions every year. Children inherited skies already organized by older observers. That part becomes easy to overlook in modern life. The constellations feel ancient partly because they remained recognizable long enough for stories to stabilize around them before the stars themselves noticeably shifted apart. Human civilizations developed beneath skies stable enough to memorize without instruments. A torch moves along the edge of a field somewhere beyond the houses. Metal tools knock softly together. Wind passes through dry grass in uneven waves. Somebody checks the position of familiar stars almost automatically. Direction itself became ordinary. North remained north. Winter skies returned, looking mostly the same. Even now, people who know very little astronomy still expect certain stars during certain months. Summer evenings feel different from winter ones before most people consciously identify why. Holidays cluster around darker seasons, partly because human routines synchronize themselves to repeating light conditions over long periods of time. The sky became infrastructure again, just operating at a different speed. And it was not only the motion of stars that mattered. The stars themselves had to exist in the right form first. Earlier in cosmic history, there were fewer heavy elements available. Less carbon, less oxygen, less iron. The first generations of stars formed inside a universe that had not yet produced much chemical complexity. Many lived briefly and died violently before stable planetary systems like ours became common. The night sky over early human civilizations already belonged to a chemically older universe. At first, that sounds abstract. But the iron in farm tools, the calcium inside bones, the silicon inside electronics, all of it required earlier stars to form, collapse, and scatter material through space long before Earth existed. Stable civilizations arrived late enough to inherit ingredients unavailable near the beginning of cosmic history. Someone scratches marks into a calendar board beside a doorway. Another ties drying plants together beneath a roof beam while evening light fades outside. Beyond the village, stars continue crossing overhead with the slow repetition of systems that were old before anyone living could name them. Predictability creates trust gradually. People stop treating the sky as a condition and start treating it as a constant. That transition may have taken thousands of years, possibly longer. The strange part is realizing not every civilization in the universe would inherit skies capable of teaching that kind of confidence. Some worlds may orbit unstable stars that never allow agricultural rhythms to settle properly. Some may lose visible stars behind permanent atmospheric haze. Some may exist in crowded regions where nearby stellar explosions repeatedly interrupt biological recovery. Others may form so early that the materials needed for complex planets barely exist yet. Meanwhile, human beings learned seasons from recurring patterns of light above open fields. The stars remained stable long enough for mythology to outlive governments, languages, even entire belief systems. A breeze moves through hanging fabric beside a doorway. The fire near the field burns lower. Constellations continue crossing the sky at the same pace people already expect. And because they keep returning, generation after generation begins assuming the visible order overhead is simply how the universe normally behaves. Inside a steel foundry, the air ripples above open metal. Heat climbs through the building in uneven waves. Sparks skip across the floor whenever machinery shifts position. Workers stand behind dark protective glass while molten iron moves through channels cut into concrete decades earlier. The sound never fully settles. Fans rotating overhead, hydraulic pressure releasing in short bursts. Steel striking steel somewhere deeper inside the structure. The entire process depends on elements that did not exist near the beginning of the universe. That remains difficult to picture in physical terms. Early galaxies looked very different from the ones surrounding Earth now. There were already stars, sometimes enormous ones, but most of the universe still consisted of relatively simple material: hydrogen, helium, expanding regions of space where more complicated chemistry had not fully developed yet. No rocky coastlines. No iron-rich planetary cores. No oxygen moving through forests or oceans. Not yet. The first stars formed anyway. Many were far larger than the sun. Some consumed their fuel quickly and collapsed before slower, more stable systems had time to organize around them. Others exploded outward, pushing newly formed material back into surrounding space before planets like Earth even became possible. Galaxies brightened early. But brightness alone did not make the universe chemically ready for life. A furnace door opens inside the foundry. Orange light spreads across the floor for a few seconds before narrowing again. Somebody checks temperature readings clipped beside a control panel. Another worker sweeps cooling fragments of metal into a collection bin without looking up from the task. Industrial routines built from material older stars had to manufacture first. Carbon formed inside stellar interiors. Oxygen too. Silicon, magnesium, iron. The heavier elements required temperatures and pressures only stars could maintain long enough for simpler atoms to fuse into more complicated structures. Then many of those stars died, sometimes violently. The explosion scattered newly formed elements through surrounding space where later stars, planets, and eventually biological systems assembled from the debris. Not through a clean sequence, more through repeated mixing across galaxies over enormous stretches of time. Dead stars became raw material for future worlds. That sentence sounds more dramatic than the actual process probably looked. Physically, it was mostly pressure, fusion, collapse, dispersal, repeated across expanding regions of space for billions of years. A chemically simple universe slowly became chemically crowded. And after enough generations of stars passed, different kinds of planets could finally begin forming. Rocky crusts, metallic cores, oceans, atmospheres capable of sustaining more complicated reactions for longer periods of time. The ingredients for biology arrived gradually rather than appearing automatically alongside the first stars. That changes the emotional scale of ordinary objects slightly. A steel beam inside a warehouse, copper wiring behind apartment walls, calcium inside teeth, salt moving through blood, aluminum cooling beside factory molds. All of it belongs to a universe already shaped by long cycles of stellar formation and collapse before Earth existed. Earlier galaxies may have looked beautiful from a distance while remaining chemically incomplete underneath. The machinery inside the foundry slows for a moment. Smaller sounds become noticeable. Ventilation systems, footsteps across dusty concrete, a loose strip of sheet metal vibrating high near the ceiling whenever heavy equipment starts moving again. Then another stream of molten iron pours through the channel. Bright orange at first, darker as temperature falls. The early universe had stars long before it had enough chemical diversity for bodies like ours. That realization arrives later than it probably should. Human intuition keeps treating starlight as the beginning of habitable worlds when, for long stretches of cosmic history, stars were still manufacturing the necessary ingredients. For billions of years, the universe may have been active, luminous, and structurally impressive while still lacking much of the material complexity life eventually depended on. The stars overhead now already contain remnants of older stars inside them. So do the planets. So does the foundry floor beneath the workers' boots. And far back in cosmic time, galaxies continued glowing above enormous regions of space where metal, stone, oceans, and living tissue had barely begun to exist at all. A spiral galaxy turns slowly through darkness already crowded with light. Blue star-forming regions spread across its arms in long, uneven bands. Dense clouds collapse inward under gravity while new stars ignite continuously inside them. Some burn white, some blue. Others disappear behind drifting dust before becoming visible again farther along the arm. From a distance, the structure looks calm. Inside it, almost everything is moving. Gas falls inward, radiation pushes outward. Older stars continue orbiting through regions now filling with younger ones. Supernova remnants expand into neighboring clouds that later collapse into additional systems. Entire sections of galaxies behave less like static objects and more like ongoing industrial environments. For a long time, the universe became increasingly efficient at producing stars. Not immediately after the beginning. That came later, once galaxies grew dense and chemically enriched enough to support larger waves of star formation. Eventually, there were eras when galaxies created new stars far faster than they do now. The night skies during those periods may have looked brighter from many worlds. Not necessarily calmer, just more crowded with activity. Inside one star-forming region, ultraviolet radiation floods across nearby gas clouds, while younger stars continue emerging deeper inside the dust. The process overlaps constantly. New systems forming beside older systems already destabilizing. Heat, collapse, turbulence, expansion. Large sections of the universe operating with the momentum of continuous construction. It resembles certain industrial districts late at night. Freight routes still active, factory windows still illuminated, cooling towers releasing heat into the air while older infrastructure continues operating underneath newer additions. After enough time, the activity begins feeling permanent simply because it never fully stops. But productive systems still pass through heavier periods. That realization settles in quietly here. The universe humans inherited already moved beyond its peak era of star production long before Earth formed. Galaxies still create stars now, including the Milky Way, but at slower rates than during earlier epochs when gas reserves were denser and galaxy collisions happened more frequently. We arrived after some of the busiest ages had already passed. Physically, that is not mysterious. Galaxies consume available gas over time. Star formation slows as material becomes harder to compress into new systems at earlier rates. Still, the emotional perspective shifts slightly once you notice it. The bright, energetic universe people often imagine near the beginning was already aging before the sun existed. A maintenance worker walks between rows of humming machines inside a distribution facility somewhere on Earth. Fluorescent light reflects across polished concrete. Conveyor systems continue moving packages in steady intervals while older equipment vibrates beneath newer, automated sections. The building still functions efficiently, but not with the same intensity it once did. Galaxies may experience something loosely comparable across incomprehensibly longer timescales. Not collapse, not exhaustion exactly, more like gradual reduction in available momentum. Even so, during the long era of abundant star formation, the universe was probably extraordinarily active. Spiral arms crowded with luminous young systems, nebulae stretching across enormous distances, heavy elements spreading outward through repeated stellar deaths while fresh generations continued igniting behind them. A chemically rich cosmos finally existed. Rocky planets became more common, stable stars more common too, oceans possible in more places, mineral surfaces, long-lasting atmospheres, complex chemistry able to persist for longer uninterrupted periods. For a while, the universe became unusually good at producing the kinds of environments living systems might use. That detail changes the position of Earth slightly. Not near the beginning. Possibly not especially early at all. More like somewhere inside the long middle stretch of a productive era already underway before humans ever looked up and started naming constellations. The spiral arms continue turning anyway. Dense blue regions still glowing through the dust. A productive universe continuing its routines even after its period of maximum output has already passed. The planet turns slowly beneath an atmosphere that traps too much heat. Cloud systems still move across the surface. Storms still organize themselves into rotating bands. Sunlight reaches the ground through dense orange haze. From orbit, the planet almost appears active in the way living worlds appear active. But oceans disappeared long ago. Water escaped gradually through the atmosphere over immense stretches of time until surface temperatures climbed high enough to melt lead. Rocks remained. Wind remained. Weather continued in a limited sense. The planet stayed geologically alive. It simply stopped being biologically forgiving. Another world farther from its star freezes instead. Ice spreads across enormous plains beneath a dimmer sky. Atmospheric gases begin freezing onto the surface itself. What remains overhead grows thinner and colder over time until even sunlight starts feeling distant there. Dust still moves across the terrain. Frost expands and retreats along crater walls with the seasons. Again, the planet survives physically. But continuity becomes difficult for living systems inside conditions that unstable. That changes the emotional meaning of the word planet a little. Human intuition treats planets as destinations almost automatically. The shape feels familiar. Horizons feel emotionally recognizable before we know anything about the chemistry or pressure or temperature waiting underneath the clouds. Then the environmental systems begin failing. Heat retention fails, or atmospheric pressure fails, or radiation reaches the surface too easily, or liquid water disappears too often, or tidal locking leaves one hemisphere in permanent daylight while the other remains frozen in darkness. Sometimes magnetic shielding weakens and stellar particles slowly remove atmospheric layers over millions of years. The failures emerge through different systems, usually several at once. A climate control unit hums behind a wall inside a modern office building on Earth. Air filters cycle continuously. Thermostats adjust temperatures room by room. Moisture stays within a narrow range. Ventilation systems balance airflow without most people noticing any of it. Habitability already depends on constant regulation here. Earth performs versions of these adjustments naturally. The atmosphere redistributes heat. Oceans move enormous amounts of energy around the planet through repeating circulation patterns. The magnetic field redirects much of the charged solar radiation that would otherwise strike the surface directly. Plate tectonics recycle carbon across geological timescales. Water keeps changing state through cycles that help stabilize temperatures over long periods of time. None of these systems remain fully independent from one another. That becomes difficult to ignore once you start following the interactions closely. Earth is not simply located at a useful distance from the Sun. The planet continuously maintains overlapping environmental conditions that correct and moderate one another often enough for biology to persist. And even then, the balance has never been perfectly stable. Ice ages happen. Atmospheric chemistry shifted repeatedly. Extinction events reorganized ecosystems many times before humans appeared. Entire categories of life expanded, collapsed, and disappeared while the planet continued adjusting around them. The current Earth system feels permanent partly because human memory occupies such a narrow slice of time. Rain strikes a rooftop somewhere after midnight. Gutters overflow briefly before draining again. Traffic noise softens beneath the weather. A refrigerator compressor clicks on inside a dark apartment kitchen, while billions of tons of atmosphere continue circulating above the building without anyone consciously tracking the conditions keeping that circulation stable. Most planets may never achieve this kind of overlapping environmental balance. Some worlds might briefly support oceans before losing atmospheric pressure. Others may remain geologically active while lacking stable chemistry for long-term biological complexity. Some may look visually beautiful while remaining lethally dry. Others may hide water permanently beneath ice layers too thick for surface ecosystems to emerge easily. Planetary familiarity turns out to be misleading. A sphere with clouds is not enough. A rocky horizon is not enough. Even liquid water alone may not remain enough for very long unless multiple environmental systems continue interacting within relatively narrow limits at the same time. And cooperation is probably the wrong word for it. These systems are not trying to preserve life. They simply obey physics in ways that occasionally produce temporary environmental stability. Temporary matters more than people like to think. Outside, weather continues moving across the planet anyway. Clouds forming. Pressure shifting. Warm air rising through colder layers while countless balancing processes continue operating together closely enough for another ordinary morning to arrive. The control room stays dim so the screens remain readable. Most of the overhead lights are turned off during the night shift. Only a few fluorescent panels still hum above the desks. Paper cups sit beside keyboards. Somebody left half a sandwich wrapped in plastic near a stack of printed tracking reports hours ago and never came back for it. The monitors continue updating anyway. Satellite positions refresh line by line. Weather systems move across digital maps. Timing signals arrive from orbiting clocks that must remain synchronized closely enough for navigation systems on Earth to function without most people noticing the corrections happening underneath. A technician rubs one eye while comparing two time measurements separated by fractions too small for human senses to detect directly. The corrections still matter. Global positioning systems already account for relativity continuously. Clocks on board satellites experience time differently because of velocity and gravity changes above Earth. Without ongoing adjustments, navigation errors would spread quickly. Phones would drift away from roads. Aircraft positioning would become less reliable. Shipping systems would begin disagreeing with physical locations. Most people never think about this while asking for directions somewhere. Modern normality depends on maintenance loops that remain almost completely invisible. Not dramatic maintenance either. Mostly repetition. Verification, calibration, cross-checking, waiting for another measurement. Somebody drinking cold coffee beside equipment that has been operating continuously for years. A printer starts briefly somewhere deeper inside the room. Ventilation pushes dry air through ceiling ducts. One worker writes updated values onto a paper checklist instead of trusting memory alone. The systems function because people keep returning to them. That changes the emotional texture of civilization slightly. Cities feel stable from street level. Trains arrive on schedule. Forecasts appear automatically. Communication satellites remain overhead. Clocks across continents mostly agree with one another. Electrical grids continue balancing demand through the night while millions of people sleep without thinking about synchronization frequency or load correction. But stable systems drift if nobody tends them. Components age. Timing offsets accumulate. Sensors fail gradually instead of all at once. Atmospheric conditions interfere with measurements. Solar activity disrupts orbital systems. Tiny errors spread outward unless somebody notices them early enough. Earlier, we were talking about planets maintaining environmental balance through interacting natural systems. Now the scale becomes smaller and more procedural. A tired person checking signal integrity at 3 in the morning while fluorescent lights buzz overhead. Civilization layered artificial stabilization systems on top of planetary ones. The adjustments never fully stop. In another room nearby, a weather analyst watches storm formations update frame by frame along a coastline where most residents are asleep. Elsewhere, tracking stations continue monitoring orbital debris moving around Earth faster than rifle rounds. Cooling systems cycle beneath server racks, storing astronomical observations collected earlier in the night. Maintenance became part of modern reality gradually enough that most people stopped seeing it. Even the clocks require supervision. A small digital display shifts by 1 second, then settles again after synchronization completes. Nobody reacts. The process is ordinary. That may be the strangest detail. Human beings already spend enormous effort preserving narrow operational stability across systems too interconnected for any individual person to fully understand. Navigation timing, electrical load balancing, water treatment, climate monitoring, communication infrastructure, orbital tracking. Normal life rests on continuous adjustment. And unlike oceans or atmospheric circulation, many human systems fail quickly if correction loops stop functioning for long enough. The room remains quiet except for equipment noise. Monitors reflecting softly across tired faces. Outside the building, clouds continue crossing the night sky above a civilization held together partly by people awake during hours most others never experience directly. A massive blue star burns through its fuel with visible aggression. Radiation floods outward in enormous quantities. Stellar winds drive surrounding gas away from the system while nearby clouds glow under intense ultraviolet light. The star itself remains visible across enormous distances, brighter than many smaller stars combined. And yet it may survive for only a relatively brief fraction of cosmic time. Large stars consume themselves quickly. That is the exchange. More mass creates stronger gravity. Stronger gravity increases pressure inside the core. Fusion accelerates. Energy output rises dramatically. The star shines harder partly because it is exhausting fuel at extraordinary rates. Some live so briefly that planets forming nearby might barely stabilize before the star begins changing. Meanwhile, much smaller stars continue almost unnoticed. Red dwarfs barely glow compared to blue giants. Some are dim enough that a person standing on nearby worlds might experience permanent twilight conditions, even during daytime. The light would probably feel weak in emotional terms, even when temperatures technically remain survivable. But those stars conserve fuel carefully. They burn slowly. Extremely slowly. A blue giant may disappear while nearby red dwarfs are still near the beginning of their lifetimes. The timing difference becomes difficult to intuit correctly. The universe does not age evenly across all systems at once. Different stars experience entirely different lifespans depending on mass. Some regions burn through energetic conditions quickly, while others remain comparatively unchanged across spans of time that are hard to mentally scale. A machine inside a factory overheats after 10 years of continuous operation. Another, older machine nearby keeps functioning for decades because it runs slower, cooler, under less stress. Stars resemble that sometimes. Not metaphorically. Physically. Inside stellar nurseries, massive bright stars dominate the region visually, even though many smaller neighboring stars will outlive them by enormous margins. Human perception associates brightness with importance almost automatically. Sometimes with permanence, too. But brightness often signals rapid consumption instead. That realization arrives later than expected. The sun feels balanced enough that people quietly assume stars like it represent the normal middle condition of the universe. Stable, long-lasting, energetic enough for complex chemistry without becoming destructive too quickly. The more stellar lifetimes are compared, the narrower that balance begins to feel. Some stars die before surrounding planets fully cool. Others survive so long that the distant future of the universe may belong mostly to them. Red dwarfs could continue burning long after larger, brighter stars disappear across huge regions of space. Trillions of years from now, many of the remaining active stars may be small, dim ones that barely attract attention in current night skies. That shifts the emotional direction of time slightly. The bright universe people instinctively associate with cosmic vitality may not represent the long-term condition at all. A distant civilization orbiting a red dwarf far in the future might still see active skies, while nearby regions drift through darkness after larger stars exhausted themselves ages earlier. Different parts of the same universe aging at incompatible speeds. The sky would stop feeling historically synchronized. Maybe it never actually was. A faint red star continues glowing beside the cooling remnants of a much larger one. Dust expands slowly outward through surrounding darkness, while smaller, colder systems nearby remain mostly unchanged. The universe keeps multiple clocks running simultaneously. Some burn loudly and disappear early. Others continue almost quietly enough to be mistaken for permanence. An astronomer scrolls through images of distant galaxies that no longer look especially active. Older survey photographs showed brighter blue regions scattered through spiral arms, dense clusters where hot young stars formed aggressively inside thick gas clouds. Some galaxies still resemble that now. Many no longer do. Large sections of the observable universe have grown quieter over time. The change is subtle at first. More red light, fewer bright star-forming regions, older stellar populations spreading across galaxies that continue rotating normally while producing fewer new stars than they once did. Nothing dramatic announces the transition. The systems simply age. A warehouse district after midnight can feel similar. Roads still exist, streetlights still work. A few loading docks remain active. But buildings that once operated continuously now sit partially dark, while older structures cool quietly in the background. The infrastructure remains. The intensity changes. That comparison stayed with me longer than expected after reading about declining star formation rates. The universe people emotionally imagine as endlessly energetic may already belong to a later operational phase instead of an early one. We did not arrive near the beginning of stellar abundance. Not remotely. The most productive eras of star formation happened billions of years before Earth formed. Galaxies contained larger reserves of cold gas then. Collisions and mergers triggered enormous bursts of stellar creation. Bright blue stars appeared across huge regions of space in much greater numbers. Now, much of that easily compressed fuel has already been used. Not depleted entirely. Just reduced. The distinction matters. The universe is still active. Stars continue forming, planetary systems still emerge, supernovae still distribute heavier elements into surrounding space. But the overall production rate has slowed significantly compared to earlier cosmic eras. And the slowing continues gradually. A long exposure image of a distant galaxy cluster fills a monitor inside an observatory office. Older red stars dominate many of the systems now. Their light feels softer somehow, less sharp. The galaxies remain enormous, but less crowded with active stellar nurseries than they once were. The emotional implication can disappear if you move through the observation too quickly. The universe already feels older. Not empty. Not exhausted. More like a civilization decades after its largest industrial expansion ended. Power still flows through the grid, roads still carry traffic, buildings still function. But the fastest period of construction happened earlier. Human beings inherited the aftermath of enormous productivity. That shifts the direction of time slightly. Earlier sections of this documentary may have sounded future-oriented. Stable stars eventually fading, habitable systems disappearing trillions of years from now. But the transition already began long before humans existed. We are living after the peak of stellar creation already passed. The night sky hides that fact well because human lifetimes are too short to watch galaxies visibly change. A person standing outside tonight sees continuity instead of gradual reduction. The constellations remain familiar. The Milky Way still stretches overhead. Light still arrives from every direction. The slowing unfolds across timescales too large for direct perception. So the universe continues appearing energetically alive long after its most productive era has already ended. A janitor pushes a floor buffer through an older office building while only a few rooms remain occupied. Vending machines hum against quiet walls. Dust collects slowly along unused windowsills in parts of the structure people rarely enter anymore. The building still functions. That is what makes the atmosphere strange. Not collapse. Continuation after the busiest period already passed. Some future habitable worlds will still exist long after Earth disappears. Around red dwarfs especially, smaller stars continuing quietly while larger systems vanish around them. But those future skies may feel emotionally unfamiliar compared to the bright, star-crowded universe humans inherited. Dimmer, perhaps. Less blue light crossing galaxies. Longer intervals between new stars appearing. Meanwhile, the observable universe continues aging quietly while people drive home from work, microwave leftovers, check tomorrow's weather, and leave porch lights glowing beneath a sky already less productive than it used to be. A person leaves the kitchen lights on through the entire afternoon because the daylight outside never feels strong enough. The room is technically illuminated. Shadows still exist. Steam rises from a cup near the window. Plants continue growing slowly along shelves beneath the glass. But the light never feels complete. Outside, the sky remains dark red, even near midday. Thick clouds move overhead in slow, layered bands while the local star hangs larger in the sky than the sun appears from Earth. Not brighter, just closer. A dim, reddish source spreading weakly across the landscape without ever fully turning the world blue. People still wake up here. They prepare meals, maintain heating systems, replace water filters, check weather forecasts before leaving for work. Vehicles continue moving beneath the red cloud cover. Interior lights stay active inside offices and apartments through most of the day because rooms never feel naturally awake otherwise. Life continues. That may be the unsettling part. Earlier in this documentary, habitability probably still carried emotional associations inherited from Earth. Blue skies, strong daylight, oceans reflecting sunlight bright enough to flood entire cities every morning. A habitable planet orbiting a red dwarf may violate many of those expectations while remaining physically survivable for extremely long periods of time. The star itself burns slowly enough to outlive stars like the Sun by enormous margins. Long after brighter systems disappear, red dwarfs may still remain active across large sections of the universe. And there are many of them. Far more than stars like ours. Future habitable worlds may exist primarily beneath skies humans would not instinctively associate with vitality. Wind moves through dark grasslands under the red light. Weather still functions, rain still falls. Rivers continue cutting through stone over long periods of erosion. But the visual atmosphere changes the emotional meaning of outdoor life. Daytime never fully arrives the way human instincts expect it to. That sentence becomes strangely personal once spoken aloud. Human beings evolved under a star bright enough to create strong daylight contrast. Morning feels psychologically distinct from night on Earth, partly because sunlight overwhelms artificial lighting completely. Offices switch lights off near windows. Streets brighten automatically. Clouds glow white overhead. Under dim red dwarf illumination, the transition may feel weaker. More like permanent late afternoon stretched across entire civilizations. A worker adjusts exterior floodlights beside a transit platform while rain taps against metal roofing overhead. The lights were already on before sunset. They remain on afterward, too. Commuters continue arriving beneath the dark red sky, carrying bags, checking schedules, waiting for transport like people anywhere else. The routines survive adaptation. Human emotional rhythms might not adapt as easily. Some red dwarfs also flare violently during earlier stages of their existence, releasing bursts of radiation capable of damaging nearby planetary atmospheres. Habitable worlds may require unusually strong magnetic shielding to remain stable close to the star. Tidal locking could complicate conditions further, leaving one hemisphere in permanent daylight while the other remains in continuous darkness. Even successful habitability begins feeling operational instead of naturally comfortable. A balancing process beneath weak, permanent light. Still, future life may persist there for spans of time almost impossible to compare against Earth's remaining future. Long after the sun expands and destroys the inner solar system, countless red dwarf systems may continue glowing quietly across surviving regions of the galaxy. The far future could belong to dim worlds where people leave interior lights on during the day because daylight itself no longer feels emotionally sufficient. A child presses a hand against cold window glass while red rain clouds move slowly overhead. The buses still arrive. Water still runs through pipes beneath the streets. Someone, somewhere, is still checking tomorrow's forecast beneath a sky that never fully brightens anymore. An observatory dome opens beneath a sky that looks almost empty compared to the archived images stored downstairs. Cold air moves across the platform while tracking motors rotate the telescope toward a region where earlier astronomers once mapped dense galaxy clusters. Cooling systems hum beneath the floor. Status lights blink across equipment racks. Data still arrives steadily through dark monitors inside the control room. But the sky itself contains less visible structure now. An astronomer pauses beside an older comparison display showing deep field images captured unimaginably long ago. Thousands of galaxies crowd the archived frame. Spiral systems, elliptical clusters, thin distortions from interacting structures spread across enormous distances. Then the live image updates beside it. Far fewer remain visible. At first, the difference resembles a technical problem. Maybe the exposure settings changed. Maybe atmospheric interference reduced clarity. Somebody checks instrument alignment again out of habit while storage arrays continue spinning softly in climate-controlled cabinets nearby. The missing light does not return. Space has continued expanding long enough that many distant galaxies moved permanently beyond observable reach. Their earlier light already passed through the region future observers could access. Nothing emitted afterward can cross the increasing separation anymore. The information simply stops arriving. That idea remains difficult to hold on to for very long. Human intuition quietly assumes the night sky preserves history automatically. If something existed, future civilizations should still be able to observe evidence of it eventually. But observation has timing conditions. Arrive late enough and parts of cosmic history disappear from direct view entirely. The observatory remains quiet except for equipment noise. Fans circulate dry air around storage racks filled with archived sky surveys from eras when the visible universe appeared far more crowded. Somebody scrolls through old galaxy catalogs while the present sky outside continues thinning in ways earlier civilizations would have noticed immediately. Future astronomers may inherit records proving the universe once contained more visible structure than anything still observable overhead. That creates a strange form of isolation. Imagine building cosmology beneath a quieter sky while depending on ancient recordings to understand that reality used to extend farther than direct experience now suggests. The evidence survives mostly through preservation systems, archived measurements, repeated data transfers between aging hardware generations, maintenance schedules protecting information no living observer can independently verify anymore. Old light surviving through procedure. A technician removes dust from a sealed data cartridge inside a cold archive room. Labels fade slowly along the plastic edges. Cooling units vibrate beneath shelves, storing observations older than entire nations once were. The records become more valuable as direct visibility decreases. That may be the deeper transition happening here. Emptiness stops being only visual. It becomes informational, too. A civilization emerging sufficiently late might see only its local galactic region surrounded by darkness and conclude the universe was always smaller than it truly was. The sky itself would conceal the earlier abundance. That changes the emotional meaning of astronomy slightly. Human beings currently exist early enough to still observe distant galaxies spread across immense depths of space. Ancient light continues reaching Earth from eras much closer to the energetic past of the universe. But visibility belongs to time-sensitive conditions too. The telescope continues tracking across a darker section of sky where archived maps still show galaxies no longer observable from the present era. Inside the archive, the older images remain bright and crowded. Outside the dome, the real sky continues simplifying itself anyway. A small red star continues glowing after much of the surrounding sky has already gone dark. Its light reaches a nearby planet slowly and steadily, not bright enough to flood the landscape with strong color, just enough warmth to keep water moving through rivers and shallow oceans near the habitable regions. Clouds still form here. Thin rain crosses dark stone fields while weak daylight reflects softly off wet ground. The horizon never becomes fully black during daytime, but it never becomes convincingly bright either. The atmosphere carries a subdued quality, like reduced lighting left active after a larger system already shut down. That comparison appeared accidentally while thinking about older office buildings during power failures. The main lights disappear first. Then smaller backup systems continue glowing quietly through hallways for hours afterward. Enough illumination to keep people moving through familiar rooms carefully, enough stability to extend operation beyond the initial failure. Red dwarfs feel strangely similar on cosmic timescales. Large, bright stars disappear earlier. Galaxies lose much of their energetic blue light. Distant structures drift beyond visibility. Meanwhile, small, low-mass stars continue operating almost absurdly far into the future. Trillions of years, potentially. The number stops feeling emotionally measurable after a while, so attention drifts back toward physical details instead. Condensation collecting along windows, heating systems cycling during cold weather, dim light visible beneath a doorway after the rest of a building already shut down for the night. Longevity changes atmosphere. Not necessarily toward comfort. A maintenance worker walks through a mostly empty transit station while emergency lights cast faint reddish reflections across polished floors. Escalators stopped hours earlier. Most storefronts remain closed behind metal shutters, but ventilation still hums through the walls. Exit signs remain illuminated above dark hallways. The structure survives in reduced form. Future red dwarf systems may preserve life through something emotionally similar. Not abundant brightness spread across crowded galaxies, more like persistent operational continuity inside a quieter universe. And there is genuine stability there. That matters too. Small stars burn fuel slowly because internal pressures remain lower than those inside massive stars. They avoid the violent consumption rates that shorten the lives of brighter systems. Some may continue warming nearby planets for spans of time so long that current human history becomes difficult to compare against them meaningfully. Life could persist around these stars after much of the universe humans emotionally recognize already changed beyond familiarity. But lasting longer and feeling hospitable are not automatically the same thing. The planet still orbits close to the star. Tidal locking may leave one hemisphere facing permanent daylight while the opposite side remains frozen beneath continuous darkness. Stellar flares may periodically flood nearby space with radiation. Even the dimness itself changes the psychological texture of outdoor environments despite technically survivable temperatures. The sky keeps returning to that tension. Weak light lasting longer than bright light. A person repairs a greenhouse seal while dim red daylight filters through condensation overhead. Interior lamps remain active during daytime growing cycles. Water pumps vibrate beneath the floor. Plants continue growing in carefully monitored rows while rain taps against the outer structure. Nothing here looks catastrophic. That is what makes the atmosphere difficult to interpret after a while. The systems still function. The weather continues. Warmth remains available, but abundance already thinned into continuity. Outside, the small star keeps glowing, steady enough to support another cycle of rain. Another harvest. Another generation learning to treat dim red daylight as ordinary beneath a universe already much quieter than the one humans were born into. Water drips slowly through a recycling pipe behind the wall while somebody sleeps nearby. The sound repeats every few seconds. Pumps adjust pressure beneath the floor. Air filters continue pulling fine dust from circulation vents through the night while grow lights remain active inside a sealed agriculture room farther down the corridor. Outside the window, the landscape still exists. Rock formations, dry river channels, wind pushing thin layers of dust across open ground beneath a pale, aging sky. But exterior doors rarely open now unless maintenance requires it. The planet did not become uninhabitable all at once. The transition moved gradually. Long climate shifts, ocean loss, atmospheric instability, temperature ranges becoming less predictable across larger regions, surface conditions remaining survivable sometimes but no longer reliable enough for ordinary exposure. That word keeps returning here. Reliable. Earlier in the documentary, habitability still meant environmental systems operating mostly on their own. Rain cycles, oceans distributing heat, atmospheres balancing pressure and chemistry without direct intervention. Here, the systems still function, but only because people maintain them continuously. A worker checks nutrient flow inside a hydroponic growth chamber where rows of green plants stretch beneath artificial light. Condensation gathers along transparent panels separating the controlled interior climate from the dry exterior world outside. Water moves through narrow tubes in measured cycles before returning to filtration units below. Nothing gets wasted anymore. Not water. not heat, not breathable air. The atmosphere inside the structure smells faintly metallic beneath the humidity from the crops. Fans hum overhead without stopping. Backup systems run automatic diagnostics every night while residents sleep beside walls full of circulating machinery. A home gradually becoming life support infrastructure. That transition feels once the physical details settle into place. Human beings already spend much of their lives inside controlled environments without thinking about it directly. Heating systems, refrigeration, air conditioning, water treatment, indoor agriculture, pressurized aircraft cabins, submarines, orbital stations. For most of human history, Earth absorbed the larger corrections automatically. Now the corrections moved indoors. The dry world outside still receives sunlight. Thin clouds still appear occasionally near the horizon. Wind continues reshaping exposed surfaces across abandoned regions where older cities remain partially buried beneath drifting dust. The planet survives physically. Comfort does not. A child fills a metal container from a recycled water station while soft filter noise vibrates through the ceiling overhead. Somebody replaces worn seals around an airlock entrance nearby. Another person wipes condensation from interior glass, separating the greenhouse from the exterior landscape beyond. People still eat dinner together here. Still sleep. Still argue quietly in hallways. Ordinary routines continue inside systems requiring constant maintenance to remain safe. That may be the strangest emotional shift so far. Earlier sections kept asking whether life could survive. Now, survival itself begins feeling procedural instead of reassuring. A world can remain technically alive long after it stops feeling naturally welcoming. And stars contribute to that narrowing, whether civilizations are prepared for it or not. As stars slowly change brightness across immense spans of time, planetary climate systems shift with them. Oceans evaporate gradually. Atmospheric chemistry changes. Stable environmental regions shrink or relocate. The transition may take millions of years. No individual person would ever watch it happen directly. They would inherit stages of adjustment instead. More infrastructure, more filtration, more sealed agriculture, more dependence on systems performing tasks the planet once handled without assistance. The air filters continue humming through the night. Water keeps circulating beneath the floor. Green plants still grow under artificial light beside a window looking out across a world that used to do this by itself. A reservoir gauge drops slowly along the side of an old processing station. Not empty, just lower than it used to be. The measurement updates in small increments while pumps continue drawing from the remaining supply beneath the facility. Pipes vibrate softly through the walls. Somebody records the new level on a maintenance sheet clipped beside the control panel, then walks to the next inspection point without reacting much at all. The system still functions. That atmosphere keeps returning now. Not failure. Reduction. A spiral galaxy turns through darkness with fewer bright blue regions spread across its arms than it once had. Older stars dominate more of the visible structure now. Yellow light, red light. Long-established stellar populations continuing their slow orbits while the remaining regions still producing new stars grow smaller and farther apart. The galaxy remains enormous, but it no longer builds at the same rate. Cold molecular gas matters here more than most people realize at first. New stars require dense, cool regions where gravity can gradually pull material inward until pressure and fusion ignite another system. Without enough cold gas, star formation slows. Not because the laws changed, because the usable supply keeps thinning. The comparison feels almost too ordinary at first. Reservoirs lowering during drought conditions, fuel reserves shrinking through repeated use, storage tanks marked with faded measurement lines from years when the levels sat much higher. But galaxies behave that way too. The bright blue regions associated with active spiral galaxies are temporary signs of material still collapsing into new stars. As galaxies age, more of that accessible gas becomes locked inside older stars, scattered by energetic events, or heated into conditions less useful for future formation. A technician stands beside a water treatment display while slow fan noise fills the room. Numbers continue updating across a dim monitor showing declining reserve capacity over long spans of recorded time. Nothing urgent happens during the shift. Pressure remains stable. Flow rates remain acceptable. Still, the trend line keeps moving downward. That emotional texture starts expanding outward now. Earlier sections focused on individual worlds struggling to maintain habitable balance. Sealed agriculture, recycled water, indoor climates replacing environmental stability planets once handled naturally. Now the narrowing reaches galaxies themselves. Even future sunlight depends on finite reserves. A distant spiral arm rotates through darkness, where only a few concentrated blue regions still glow inside enormous stretches of older stellar light. Dust lanes remain visible. The structure survives. But the crowded, energetic appearance associated with younger galaxies has thinned noticeably. The universe continues operating. That is what makes the condition difficult to emotionally place. A galaxy can remain visually magnificent while gradually losing the ability to produce large numbers of new habitable systems. The structure outlives the abundance. I think I misunderstood that earlier in the documentary. Human intuition quietly treats galaxies as permanent engines. Endless factories continuously producing stars, planets, chemistry, possibility. But star formation depends on stored material. And stored material changes over time. The cold gas keeps running lower. A worker closes a valve beside a storage tank while distant machinery continues humming through the building. Overhead lights flicker briefly before stabilizing again. Outside, rain moves across empty pavement where old industrial pipes still carry reduced flow through systems designed for heavier demand decades earlier. Nothing dramatic announces the shift. Everything still works, just at a quieter level than before. The spiral galaxy keeps turning through the dark with scattered blue regions glowing farther apart now, each one forming from part of a supply that does not fully replenish once it is used. A room warms slowly after the power returns. At first, almost nothing changes. The lights come back before the heat does. A refrigerator starts humming again in the kitchen. Vents click softly somewhere behind the walls. People keep their jackets on because the air still holds the cold stored during the outage. Then gradually the warmth spreads through the building again. You notice it first in your hands, later in the floorboards, much later in the silence after the pipes stop contracting inside the walls. That delay feels important now. Because in the far future, warmth may stop feeling automatic enough to ignore. A dim habitat drifts through a region where most external light sources have already faded into distance or exhaustion. Interior systems remain active at low power. Corridors stay dark until motion sensors wake small sections of lighting ahead of passing footsteps. Machinery cycles slowly to conserve energy. Some rooms remain unheated when nobody is using them. Nothing wastes heat casually anymore. A person waits beside a thermal monitor while insulated walls release stored warmth back into living spaces in measured intervals. Air circulation stays low to reduce energy loss. Water lines remain wrapped beneath heated panels so they do not freeze during reduced activity cycles. The systems feel patient. That is the atmosphere here. Not emergency. Conservation. Earlier in the documentary, heat behaved like part of the background structure of existence. Sunlight crossed oceans freely. Cities spilled artificial light into the night without much thought. Buildings overheated from excess energy while windows leaked warmth into winter air outside. Now warmth behaves more like inventory. Something measured, stored, scheduled between cycles. I keep returning to small physical details instead of larger philosophical ones. The sound of insulated doors sealing shut. Frost forming briefly along exterior metal before heating systems push it back again. People waiting for sleeping quarters to warm gradually after low power periods end. Comfort slows down. Future civilizations may still access energy through dim stars, compact stellar remnants, stored thermal reservoirs, captured radiation, or systems designed to extract usable heat from environments that no longer provide it freely. The universe does not suddenly become energyless, but usable warmth grows more local, more deliberate. A worker sits beside an aging heat exchange unit drinking from a metal cup held close to both hands. Pipes vibrate softly overhead while storage systems discharge thermal energy into surrounding rooms at controlled rates. Nobody leaves doors open longer than necessary. Even conversation stays quieter inside heavily insulated spaces. The environment changes behavior. People change with it. That shift arrived later than I expected while writing this section. Modern life trains people to experience heat as invisible infrastructure. You touch a thermostat, the room changes temperature. Energy arrives through walls continuously enough that waiting almost disappears from ordinary experience. Here waiting returns. A bed remains cold for a while after activation. Water warms slowly through reused systems. Lights stay dim unless work requires brightness. Warmth becomes physical again because scarcity forces attention back toward sensation. The habitat continues drifting through darkness while old sources of stored energy move carefully through insulated pipes beneath the floor. Outside, stars still exist in scattered, distant regions. Some continue burning faintly, others collapsed long ago while leaving dense remnants future systems still draw heat from carefully and slowly. The universe continues operating. But people no longer live inside effortless warmth. They borrow heat from surviving sources, distribute it carefully through small inhabited spaces, and hold on to it for as long as possible once the room finally becomes warm enough to sleep in comfortably again. Thin sunlight falls across a concrete platform outside the habitat entrance. Not bright sunlight, just a narrow band of pale warmth breaking through the cloud cover long enough for nearby workers to stop what they were doing for a minute or two. A maintenance cart stays parked beside the rail. Somebody sits on a low metal barrier holding both hands inside the light without saying anything. No one seems eager to go back indoors immediately. Clouds continue moving slowly overhead. The air still feels cold outside the illuminated strip, but inside the sunlight there is a small difference against the skin. Enough to notice through gloves. Enough that people drift slightly closer together without discussing it directly. That reaction feels older than technology somehow. Bodies turning toward open warmth automatically. Earlier sections focused on stored heat, recycled systems, controlled agriculture, thermal management, interior survival, machinery compensating for environmental decline. But natural sunlight behaves differently even when it becomes weak. It arrives without machinery. No ventilation noise. No circulation pumps. No display confirming temperature output. Just light crossing open air again. A woman closes her eyes briefly while standing beneath the thin sunlight beside the entrance ramp. Someone else removes one glove for a moment and presses bare fingers against the warmed surface of the railing before pulling the glove back on. The moment lasts maybe 10 minutes. Then the clouds move again. The platform cools almost immediately afterward. People remain outside a little longer anyway. That detail stayed with me more than expected while writing this section. Modern life conditions people to experience daylight as environmental background. Too much sunlight through windows. Not enough during winter mornings. Bright weekends, cloudy afternoons. Very few people experience direct sunlight as temporary access to a rare physical condition. But surface habitability depends on multiple systems continuing to overlap at the same time. Atmospheric stability, stellar consistency, heat distribution, pressure balance, planetary water cycles. When those systems drift apart slowly enough, civilizations adapt in stages without fully recognizing what disappeared first. Outdoor life contracts gradually. Then eventually people stand silently beneath a weak opening in the clouds longer than necessary because the experience itself has become unusual. A child stretches both hands into the light while cold wind pushes dust across the far edge of the platform. Someone near the outer door checks the weather timing display, already calculating how long the next clear interval might last later in the week. The sky still remains open above them. That matters too. No ceiling. No filtered lighting panels. No recycled air moving through vents. Just daylight touching exposed skin directly after long periods indoors. The emotional texture shifts quietly here. Not catastrophe, not grief exactly. More like ordinary physical experiences becoming valuable slowly enough that people fail to notice when their meaning changes. Standing outside. Feeling warmth through clouds. Waiting a little before returning inside. The sunlight fades again as thicker cloud layers pass overhead. People collect their tools. The maintenance cart powers on softly. Exterior doors seal behind them, one at a time, while the platform cools back toward the surrounding air. For a few minutes, the world felt naturally warm again. Then the habitat resumed doing the work the planet used to handle by itself. Artificial morning lights turn on gradually across the residential corridor. Not bright at first. A soft, pale glow spreads through ceiling panels in slow stages while ventilation systems continue humming behind the walls. Doors remain closed for a few minutes longer. Then movement begins. Footsteps, water running somewhere nearby. A child carrying a bag too large for one shoulder walks past dark windows where the outside sky still looks almost unchanged from night. Nobody pauses to look at it. That detail stayed with me longer than expected. Earlier sections treated weak daylight as emotionally unusual. People stopping work to stand beneath brief sunlight, waiting outdoors a little longer than necessary before returning inside. This place already adapted beyond that stage. Schedules follow controlled light cycles more than exterior conditions now. Artificial dawn begins at the same hour every day, regardless of cloud density outside. Classrooms brighten automatically before students arrive. Work shifts rotate through interior timing systems calibrated to support sleep patterns that natural daylight no longer regulates reliably on its own. Life reorganizes itself around the replacement systems. A teacher wipes condensation from the corner of a classroom window before students enter. Outside, the dim red star remains visible through heavy cloud cover even during daytime. The light still reaches the settlement technically, but it spreads weakly enough that interior illumination dominates most rooms anyway. Children sit beside windows without looking outside very often. That may be the part that changes the emotional tone of the documentary most quietly. Not fear. Not grief. Familiarity. A generation raised beneath dim stars may not experience the environment as damaged because memory itself formed differently from the beginning. School mornings, shared meals, indoor gardens, corridor conversations before work, all of it organized around enclosed architecture and managed lighting long enough that bright, open daylight stops feeling central to ordinary life. I kept wanting to compare it to winter cities or underground transit systems where people spend long stretches without seeing the sun directly. But those environments still carry the assumption that strong daylight exists nearby, waiting to return. Here, the expectation itself fades. A student presses one hand against cool window glass while waiting for class to begin. Beyond the settlement walls, dark terrain stretches beneath low, moving clouds. Exterior doors open briefly farther down the corridor as a maintenance crew returns inside, carrying fine wind dust across the floor before the seals close again. The routines absorb the environment. That realization arrives awkwardly for me a little late into this section. Part of me kept assuming human beings would permanently resist conditions like this emotionally, that dim skies would always feel wrong in an active, conscious way. But people adapt to repeated environments surprisingly quickly once those environments become tied to childhood, work, friendship, routine, ordinary memory. The emotional baseline moves. Habitable regions around small, cool stars already orbit much closer to their stars than Earth orbits the Sun. Future civilizations surviving there may organize architecture, transportation, agriculture, education, even emotional expectations around weaker and less stable natural light from the very beginning. Children born there would not compare the sky against Earth automatically. They would compare it against yesterday. Artificial dawn brightens fully across the classroom ceiling now. Students unpack tablets and paper notebooks while outside the dim star remains suspended behind clouds that never quite become white. The room feels ordinary. That may be the final stage of adaptation. Not learning how to survive beneath a different sky. Learning how to stop expecting another one. A repair machine sits open on a workbench while its parts continue moving independently. One cooling fan still spins when power reaches it directly. Indicator lights blink along the side panel. A small motor near the center responds correctly during diagnostic tests. The individual components still function. But the machine itself does not start. Somewhere inside, the timing no longer connects properly. A technician taps dust from an old cable and runs another alignment sequence while soft electrical hum fills the room. Nothing dramatic breaks. The systems simply stop cooperating in the right order. That atmosphere kept following me through this section of the documentary. Not collapse. Desynchronization. Stars continue existing far into the future. Planets continue existing too. Chemistry survives. Heavy elements remain scattered through galaxies. Heat sources persist in isolated forms. Some worlds still orbit stable stars. Some stars continue burning quietly across enormous spans of time. But the overlap changes. That may have been the fragile condition all along. Earlier sections kept treating habitability partly like a location problem. The right planet, the right atmosphere, the right star, the correct temperature range. Now timing begins to matter more than the individual pieces themselves. Stellar evolution follows one schedule. Planetary climates follow another. Galaxies build heavier elements across much longer cycles. Star formation rises and declines on separate timelines again. Even stable atmospheres drift gradually as stars change brightness over immense periods. The systems do not evolve together automatically. Sometimes they only pass through useful alignment briefly before separating again. A coastal town can still contain functioning roads after the harbor dries up. Fuel pumps may still operate after supply routes fail. Houses remain standing. Streetlights continue turning on during reduced power cycles. The pieces survive individually. The shared condition disappears first. I think I misunderstood that earlier while writing this documentary. I kept emotionally imagining the far future mostly as darkness or emptiness spreading outward through space. But much of the universe may continue functioning physically while simply losing synchronization between the conditions complex life depends on simultaneously. A rocky planet may still exist. A star may still burn nearby. Liquid water may even appear seasonally somewhere on the surface. The timing just no longer meets cleanly enough for long, uninterrupted stability. A galaxy rotates beneath older stellar light while isolated red stars continue glowing inside regions where large-scale star formation faded long ago. Elsewhere, newer, heavy elements exist, but planetary environments remain unstable. Somewhere farther out, planets survive after surrounding heat sources weaken too much for open surface habitability to continue naturally. The ingredients keep arriving out of sequence. That sentence feels strangely mechanical for something this large, but maybe that is why it stayed with me. People already understand versions of this emotionally through ordinary life. Schedules failing to align, conversations arriving too late, crops surviving a season while water systems fail the next year. A room staying cold because the heater works but the power cycle never triggered overnight. The individual conditions still existed. They just stopped arriving together. Earth begins feeling different once that idea settles fully into place. Not necessarily rare because one ingredient was miraculous by itself. The sun is not unique. Rocky planets are probably not unique either. Carbon chemistry may be common. But stable stars, usable climates, available heavy elements, active galactic chemistry, and long environmental continuity may only overlap cleanly during narrower windows than human intuition expects. The overlap itself may have been the unusual thing. A ceiling light flickers once inside the repair room before stabilizing again. The technician reconnects another cable. This time the machine starts properly. Cooling fans synchronize. Power reaches the main system. The entire structure hums together instead of separately. Nothing new was added. The parts were already there. They simply reached the right condition at the same time for a while. A porch light clicks on above a quiet street. The bulb hums softly for a moment before stabilizing. Moths drift through the light in uneven circles while cool air moves between parked cars along the curb. Somewhere, farther away, traffic passes behind rows of houses with the low, continuous sound of tires crossing damp pavement. Nothing unusual appears at first. A dog barks once behind a fence and goes quiet again. Tree branches shift slightly above the sidewalk. Blue television light flickers through a living room window where somebody falls asleep on a couch without turning the screen off. The night continues the way ordinary nights continue. That is the part that feels different now. Not because the street changed, because the conditions underneath it stop feeling automatic once you sit with them long enough. The pavement cooling gradually after sunset, air pressure remaining stable across the neighborhood, water still moving through buried pipes beneath the road, insects surviving near the porch light, leaves continuing to exchange gases with the atmosphere even in darkness. Clouds passing beneath a star still stable enough to keep Earth inside a narrow climate range human bodies can move through without noticing much at all. The overlap remains open tonight. I nearly moved past that too quickly again. Because the street itself feels so ordinary. Garbage bins beside driveways, porch steps still holding warmth from earlier sunlight. Somebody upstairs opening a window slightly before bed because the outdoor temperature finally became comfortable enough again. Routine hides the larger condition almost perfectly. The sun is still inside its long, stable period. Earth still carries oceans across most of its surface. The atmosphere still redistributes heat well enough for weather, agriculture, infrastructure, biology, and human sleep schedules to continue overlapping without constant intervention. And the systems are still arriving together at the same time. A plane moves slowly overhead behind thin cloud cover. You hear it before the blinking lights appear briefly through a break in the clouds, then disappear again farther east. The air smells faintly like wet concrete and cut grass. Someone closes a car door down the block. A refrigerator compressor starts inside one of the houses nearby. The physical world keeps operating quietly around the neighborhood without asking anyone to think about it very much. Maybe that is why the present feels permanent emotionally. The balancing systems overlap so completely that they vanish into the background together. Stable daylight, stable chemistry, stable rainfall, stable temperatures remaining inside familiar ranges often enough that people make plans decades ahead without consciously thinking about the planetary conditions making long-term planning possible at all. Not perfect stability, just enough continuity. A few stars remain visible now through thinner sections of cloud overhead. Most people on the street probably never look up long enough to notice them tonight. They do not need to. The atmosphere still protects them automatically. Trees still move through ordinary wind beside houses full of sleeping people. The temperature still declines gradually after sunset instead of failing unpredictably. Water still arrives when somebody turns a faucet handle before bed. The overlap is still functioning quietly. That may be the real emotional center of the documentary after all. Not fear of the distant future. Not cosmic catastrophe. Just the realization that an enormous number of independent conditions are still cooperating around us right now, closely enough for an ordinary neighborhood to feel completely unremarkable on a damp, quiet night. The porch light continues glowing about the street. Moths still circling through it. Clouds still moving overhead beneath a star that, for the moment, continues holding the larger system together well enough for everyone nearby to keep sleeping without thinking about any of it.